G'day everyone, welcome to another week of sound design for new media. This week we're going to be looking at sound and visibility. So what will you learn in this video? You will learn how the visibility of a system's function determines how users make choices. And to do that, we're going to need to define visibility. So what is visibility? Visibility is made up of a few different parts, and it's a design concept used by a lot of different designers, from industrial designers through to product and digital designers. Visibility is pioneered and kind of popularized by Don Norman, who wrote The Design of Everyday Things, which is a very popular book these days. But initially the idea of visibility, it derives from affordances. So what is an affordance? An affordance is the intuitiveness of an object. It is the kinds of things that exist around and are a component of a physical or digital product. You can think of things like the classical examples of affordances are things like door handles, where their function kind of reveals itself by the actual object's design itself. And another one is the teapot. It has a handle which implies its function and use. So an affordance is this kind of implied and intuitiveness that exists within digital products and services as well as physical products. But contained within affordances is something, another design concept, signifiers, and the handle's intuitiveness of a kettle actually can be described as a signifier. It's something that lets the user know what they should be doing. This can be applied again to the door handle. It could have an ergonomic shape which fits around the hand. It could be imply a certain way of actually handling the object. And that's what a signifier is in terms of a physical product design. But signifiers also exist in the digital product landscape as well. So you might have things like the design of a button or the design of a interface element, which has an implication about movement or motion. It tells you to swipe up. It tells you to swipe left. A button has a skeuomorphic visual component to it, meaning that it pops out of the screen and it says click me, and it has this kind of pop in pop out kind of function where it's imitating the kind of real physical product world. And so a signifier is something that lets you know what to do. And signifiers lead to affordances. And so lastly, let's put those things together. The visibility of a system state is the availability of signifiers which communicate affordance. It's a bit of a mouthful and a bit of a kind of a complex thing to get in your head all of a sudden. So let's just dive into a practical example where we're going to take this idea of visibility, a system state, the availability of signifiers, and look at how they actually communicate affordances. Okay, so this is our flowchart. Let's start here. Highly visible signifiers lead to comprehensible affordances, which lead to visible system states. And so let's break this down. Highly visible signifiers are the ones that you can really get a grasp of. Think of the door handle example again. We have a really clear ergonomic shape, and we also have a context and function which is obvious. We're trying to move through a door, and these signifiers lead to comprehensible affordances. Those actions are applied to the handle. You see the function take effect. There's a mechanical aspect to it. You actually see the door open, all this kind of stuff. And they lead to visible system states. Now, visible system states is kind of like a high-level category at this point. So it's kind of abstract, right? But a visible system state, you could describe that as the door is open, the door is closed. In a digital context, we obviously have, very comprehensive visible system states where we're actually able to, progress through screens or to imply a function or to activate something. It's very general. It's meant to be describing a very general principle here, a visible system state. And so let's practically put this in context with an actual example. So we have a lift button in this example. Someone's pressing a lift button. Let's have a look. What are the visible signifiers here? So we have the physical features of the actual button. That is, it's a pronounced from the actual backboard. It has edges to it. It has a label next to it. So you might be trying to move to a certain location. You're trying to go to level 4. It has a label next to it. So there's this implied function from a label. It has context. You're standing inside a lift. You know that lifts have buttons. which is a component of cultural knowledge. You've actually got some learned behaviors embedded in this, most importantly, you've used buttons in other places. So all of these things lead to a cluster of highly visible signifiers that make it intuitive to use this button in this lift. Now, the affordances that it led to is things like the light has the button has a light, and when you click it, the light actually provides you with feedback. So you've pressed it, oh, actually, look at this. I can see that the button has been pressed. There might be a bell chime, it might make a noise when you press it. And there's also a tactility of motion component here. There's, you feel the button click and you feel the button press. And so we all know, we've all experienced buttons which are ambiguous and buttons which are very clear. And in this case, you can imagine this lift button looks like it might have a very clear tactile experience. Okay, and what does that lead to? Highly visible signifiers. The affordances become obvious. We see that it's got this feedback component. There might be a bell chime. There's this tactile aspect to it. And this leads us to the visibility of system state. So the button has been pressed. We can tell it's lit up. We've pressed it. It's made a chime. And the action is recognized by the system. We can see the feedback of the light, the bell itself, actually provides us with feedback about what we've tried to achieve. And, lastly, obviously, the lift begins to move. So we know that we've actually correctly actioned what we would like to have actioned. So this is a simple example of kind of breaking down an interaction with a button, very simple button, into its kind of subset components where we have visible signifiers, affordances, and how that leads to a visibility of system state. Now, obviously, in all of our designs, we're trying to get visibility of system state. We're trying to achieve this. Visibility is a extremely important component of getting a design right. And so let's look at this problem from the opposite end. What's a bad example of visibility? And for this, we'll look at a ticket machine for a parking meter. Now, this image is a bit small, so it's hard to dive in really close, but I'll describe to you exactly what's here. So we have a big gray box with a series of cutouts in it, and these cutouts have different kinds of devices attached to it, different kind of sensors or input process output kind of systems, where we would say insert our credit card, and it would then update something internally, for example the payment system, and then return the card to you. We have tap and pay, we have an insert ticket function, and all this kind of stuff. But ticket machines are this notorious example of really bad system visibility. It's really hard to use these systems, and people get it wrong a lot. There's a lot of trial and error that actually ends up happening. So that's one of the features of low visibility systems, is that error proneness goes up. When the visibility goes down, error proneness goes up. And in the case of this example, we have kind of like the telltale sign of a really poorly designed system, when that is instruction graffiti. That's what they call it. It is instructional notes that have been written by someone else, so the owner of this facility, to actually guide users through the process of using this object. So we can say that the affordances of this object, its intuitiveness, the way that we would know how it works, is extremely low. So much so that we actually have to augment the design of the device to support the user's understanding of how to actually operate it. This is a tragic scenario. This is the opposite of what the product designer would be trying to achieve here. And this is a classic example of not thinking through the user experience of an object. And these writing, these notes that's all over this object actually includes labels, if you look closely, above each of the different devices to actually label what they do. That's how ambiguous they are. The actual input processes and mechanisms for this device, for this system, are so ambiguous and unclear that they've had to label them. In addition, now compare that to the lift example, where we have this clear one-to-one kind of experience where you want to go to level 4, you push the button. That's very intuitive. We know there's a culturally embedded context there as well. You've used buttons and things like that before, but you've used parking meters before as well. So we can't, the cultural adoption aspect doesn't really sit too well. Using buttons, I think is, obviously very intuitive, and there's buttons on this system as well. But there's a couple of key features that are very distinct and different, right? Number one is this is a much more complex interaction. We need to allocate time, we need to pay, we need to, potentially identify where our vehicle is parked. And these complications actually add to the problematic nature of visibility. And so another one of the features of visibility is that as complexity increases, so does the opacity of the system. The more complex something is, the less visible it tends to be. And the second is that we've also added a screen. So the screen is, it opens a whole can of worms here, which is that we have to now think about the user interface design. We have to think about the system state and flow. We actually have to think about how users will interact with that screen in different various functions and states. And so this is all by way of leading us to thinking, how can sound be used to generate visibility? And this is the question for this class. How do we use sound to generate visibility? How do we use sound that we embedded in objects to actually lead people to more intuitive signifiers, which therefore identify affordances, which then produce better visibility of system state? All right, that's all for this week. Thanks and good luck.